Welcome to this RealStar workflow training video. Here we will show you an example of the workflow combination to be used with Altona Diagnostics RealStar Real-Time PCR products. In this part, we will demonstrate how to perform the nucleic acid extraction of samples in preparation for the use of a RealStar PCR kit. For our example, we will be using the QIAamp Viral RNA Mini Kit. Before you begin to process your samples, please read the manufacturer's instructions for use for both the extraction chemistry and the RealStar kit in full. By reading the instructions for use, you'll avoid any unnecessary interruptions in your workflow. Prepare all the necessary equipment. For example, does your extraction chemistry require any preparation, like adding ethanol? Do any kit components need to be thawed? Do you need additional materials, such as tubes, which are not provided in the kit? Do you have the required centrifuge at hand? Now calculate the reagents and materials that you need for your set of samples. Please make sure to include one water sample, the extraction negative control, which will allow you to monitor possible contaminations or irregularities when you analyze your PCR run. Label the spin columns and elution tubes so that you can trace each and every sample back to its original material at any given time. Now you are good to go. Start with the lysis and inactivation of the potential infectious sample material. Make sure you have all locally required safety measures in place. Wear your lab coat and safety gloves, and work in a safety cabinet. Next, mix the carrier RNA and internal control tubes briefly with a vortex mixer. Then spin them down to avoid spilling any drops of liquid that may be in the lid. Pipette the lysis buffer, the RealStar internal control, and the carrier RNA into a new labeled tube. After placing the lysis mixture in the prepared tubes, add the recommended volume of sample material and mix well by pipetting up and down. Let the mixture incubate for 10 minutes at room temperature. Proceed with the protocol for the nucleic acid extraction as described in the instructions for use. Have the RealStar instructions for use at hand to remind yourself at which point you need to follow the extraction recommendations. For example, the additional centrifugation step should last 1 minute if a wash buffer containing ethanol is being used, as in our demonstration. When you reach the elution step, make sure to use the new labeled tubes that you prepared initially. After the final centrifugation step, discard the column and close the tubes containing the eluates securely. You can either store the eluates at -20 degrees Celsius or immediately proceed with the PCR setup. If possible, use separate areas for the nucleic acid extraction and the PCR setup. In this part, we will demonstrate how to use a RealStar PCR kit. Before starting the PCR setup, you should go through the RealStar instructions for use and prepare all the necessary components. Make sure that you have all the equipment you need at hand. You will require adjustable pipettes, a vortex mixer, and DNase, RNase-free disposable pipette tips with filters, along with a waste bin, a tube for preparing the master mix, and a PCR plate. Make sure that any instruments you use have been installed, calibrated, checked, and maintained according to the manufacturer's instructions and recommendations. Prepare a box with ice for the reagents before taking the RealStar kit out of the freezer. Compare the kit content with the instructions for use. Carefully take the required reagents out of the kit box and place them on ice. Repeated thawing and freezing of the reagents, more than twice, should be avoided, as this might affect the performance of the assay. The reagents should be frozen in aliquots if they are to be used intermittently. Calculate the reagents and materials needed for your set of samples. Please make sure that you include a non-template control by using the PCR grade water provided, which serves as the negative control in the PCR run. Also include the negative control from your nucleic acid extraction and the positive control or controls from the RealStar kit. When calculating the amount of reagent required, make sure to include one extra reaction as a pipetting surplus. Wait until all reagents and samples have been thawed completely. Then, mix the kit components by gentle vortexing and centrifuge them briefly to make sure that all the liquid is gathered at the bottom. Pipette master A and master B into a tube prepared for the master mix according to the calculation. Start with the higher volume. In our example for 9 reactions, we first pipette 135 microliters of master B and then add 45 microliters of master A. Mix the master mix by gentle vortexing and centrifuge it briefly. Prepare a pipetting scheme for your plate setup. Pipette 20 microliters of the master mix into each required well of the PCR plate. Do not miss a well and avoid touching the rim with the tip when pipetting into the wells. Then add 1 microliter of internal control into the wells of the kit controls. In our example, there is 1 negative and 1 positive control. Add 10 microliters of the positive control and 10 microliters of water for the negative control into the respective wells. Then add 10 microliters of each sample into the respective wells. Make sure to use a fresh filter tip for every pipetting step. Thoroughly mix the samples and controls with the master mix by carefully pipetting up and down a few times. Completely seal the plate with optical adhesive film using the MicroAmp adhesive film applicator supplied by Thermo Fisher Scientific. Make sure that the plate is covered evenly by the film and that there are no air bubbles. If possible, use a separate room for the amplification step. In this part, we demonstrate how to program and start the PCR run. You need to centrifuge the PCR plate in a centrifuge with a microtiter plate rotor for 30 seconds at approximately 1,000 g-force or 3,000 revolutions per minute. This way, all the liquid collects at the bottom of the wells. Now you are ready to start the PCR run. First, open the QuantStudio 5 DX software. To program the temperature profile on your cycler for the first time, select New Experiment in the window that opens. In the next window, you can name the experiment and define the hardware. Standard curve must be selected as experiment type and TACMAN reagents as chemistry. Please note that the run mode must be set to standard. Then click Next. To select the correct temperature profile, please refer to the instructions for use for your RealStar product. Enter the sample volume of 30 microliters. Edit the protocol by clicking on the respective temperatures and times. Enter the correct values according to the instructions for use. By clicking on the plus and minus symbols, steps can be added or deleted. Make sure that the acquisition indicated with the camera symbol is set to the correct cycling step. Change the number of cycles to 45. You can save the protocol as a template for the next run. To do this, click on Save and Save As. Click Next to set up the plate content. Select Quick Setup to set the passive reference according to the instructions for use. Under Advanced Setup, you can define the plate profile. First, select the wells in use and check the box for the targets to assign the reporter dyes according to the instructions for use. Please be aware that VIC is selected for the Joe dye and that None is selected as quencher. Then, enter the target names. Set the task according to the sample type in the respective well. U for samples, S for the positive control, and N for the negative controls. Click on Add to enter additional samples and change their names where appropriate. Then highlight the wells in use one by one. Check the box for the samples and enter the sample names. Click on Save and Save As to save the plate layout to the template. You can use the target settings for future runs using the same kit. In this case, you only need to adjust the samples. Click Next to go to the Run Control window. Place the PCR plate into the thermocycler and close the instrument drawer. Click Start Run and choose the correct cycler. You will then be able to save your run. In this part, we demonstrate how to analyze the PCR run. Once the run is finished, you can analyze the results. The icon with the eye symbol shows the plot setting. Click on this icon to change the graph type from logarithmic to linear and to select the target you want to analyze. Unchecking auto threshold allows you to set the threshold manually. First, look at the results for the internal control in the Vic channel. An internal control signal should be present for all samples. If there is any sample with a flat internal control, please note the sample name. A high specific nucleic acid load in the sample can lead to a reduced or absent internal control signal. Please refer to the results interpretation chapter in the instructions for use. To view individual curves, click on the individual wells on the right-hand side plate view. Select the negative and positive control wells in the plate view of the data analysis window. Go to Plot Properties and select the tab Y-axis. Check the box for Auto Adjust Range and click Save. Drag the threshold line into the exponential area of the control signals to set the threshold. Now go back to Plot Settings and switch to the YFV specific results in the FAM channel and deselect the auto threshold. Select the negative and positive control wells in the plate view of the data analysis window. Go to Plot Properties and select the tab Y-axis. Check the box for Auto Adjust Range and click Save. Drag the threshold significantly above the signal of the negative control into the exponential area of the positive control signal. Click on the table symbol at the right side of the window to see the results in tabular form. Go to the tab Export, browse for a directory to save the results, and click on Export. Now your PCR test results are complete and the reports are ready for further use. Thank you for watching this RealStar training video. For more information about our products, please visit the Altona Diagnostics website.